What if your computer could do your work while you sleep? What if you could text your laptop the way you text a friend and wake up to find it already booked your travel, filed your expense report, cleaned up your inbox, and written a first draft of that project summary you've been putting off for 3 weeks? That's not science fiction anymore. That is happening right now, in 2026. And today, in this video, we are going to explore two of the most exciting and talked about open source tools in the entire AI world, OpenClaw and NemoClaw. But this isn't just a talking head explainer video. By the end of what I have to say here, we are going to switch over to the terminal and I'm going to walk you through a complete NemoClaw installation, step by step, in real time. No cuts, no time lapses, no magic. If something breaks, we debug it together. That's the promise. So if you've been hearing about OpenClaw blowing up on GitHub, or you saw Jensen Huang talk about NemoClaw at GTC last week and you thought, I need to understand what this actually is and how to run it, you are in exactly the right place. Stick around. Let me set the scene. Earlier this year, a developer named Peter Steinberger released a small open source project originally called ClawdBot, then briefly renamed to Moltbot, before finally landing on the name OpenClaw. And the moment it went public, the internet went absolutely wild. Within 72 hours, it crossed 60,000 GitHub stars. Within a few weeks, it had over 180,000. Jensen Huang, the CEO of NVIDIA, called it the operating system for personal AI. And then NVIDIA itself jumped in and built something on top of it, called NemoClaw, which was announced at GTC 2026. Now, before anyone asks in the comments, yes, OpenClaw and NemoClaw are related, but they're not the same thing. One is the community-built foundation, and the other is NVIDIA's security-hardened layer on top. We're going to unpack both of them today, and by the time we hit the terminal, you're going to know exactly what you're installing and why. Let's go. Let's start with OpenClaw. At its core, OpenClaw is a free, open-source AI agent that runs locally on your machine and connects large language models like Claude, GPT-4, or DeepSeek to real software. Not just chat. Real software. Here's what that means in practice. With a normal chatbot, you type a question, it gives you an answer, and you go do the thing yourself. OpenClaw flips that model entirely. You tell it what you want, and it goes and actually does it autonomously. It can read and write your files. It can run shell commands. It can browse websites. It can send emails. It can manage your calendar. It can control APIs. It can schedule tasks. It can monitor your inbox and act on what it finds. And it can do all of this without you lifting a finger after the initial command. OpenClaw works through the messaging apps you already use. You can talk to it through WhatsApp, Telegram, Discord, Slack, Signal, iMessage, even old-school IRC if that's your thing. You send it a message like you're texting a friend, and it goes to work. You can be in a meeting, on a flight, or fast asleep, and your agent is still running. The project started in November 2025 under the name ClawdBot. It was built by Peter Steinberger, an Austrian developer who had previously founded PSPDFKit, a company known for their PDF SDK used by thousands of apps worldwide. He initially built OpenClaw for himself, a kind of always-on AI sidekick that ran on his local machine and could handle tasks while he focused on other things. But when he shared it publicly, the response was overwhelming. The red lobster mascot, a nod to the claw in the name, became iconic almost overnight. Developers started giving their OpenClaw agents names and personalities. People shared videos of their agents doing wild things, and the stories started going viral. One developer's OpenClaw negotiated $4,200 off a car purchase. The agent scraped dealer inventories across the region, filled out contact forms with the developer's details, and spent several days playing dealers against each other, forwarding competing quotes and asking each one to beat the other's offer. The developer only showed up to sign the paperwork. Another user's agent discovered a rejected insurance claim in the email inbox, drafted a legal rebuttal citing specific policy language from the original contract, and sent it without being explicitly told to do any of this. The insurer reopened the investigation. A third user set up their OpenClaw to monitor RSS feeds, summarize relevant articles, and send them a curated morning briefing every day at 7 a.m. tailored to their specific interests, without any manual curation involved. What makes OpenClaw technically special is the way it's structured. It's built on Node.js, runs as a long-running local service, and uses a skills system, essentially a directory of capabilities that the agent can tap into. There are over 100 built-in skills out of the box, covering everything from web browsing to file management to API integrations. The community has been adding more every single day. The agent also maintains persistent memory across sessions, so it builds context about you over time, your preferences, your routines, your recurring projects. It's also completely model agnostic. You can connect it to Claude, to GPT-4o, to Gemini, or to a locally running open source model, whatever you prefer. And because everything runs on your machine, your data stays on your machine by default. No data going to some third-party server you don't control. That was a massive selling point from day one, especially for developers handling sensitive code or personal data. So that's OpenClaw. A self-hosted, privacy-focused, open-source AI agent that can autonomously execute real-world tasks on your behalf. It's powerful, it's flexible, and it's growing at a pace that has genuinely shocked the industry. Now, here's where it gets really interesting. OpenClaw is incredible, but it comes with a catch. It was built fast, it grew fast, and with that growth came some real concerns. Security researchers found vulnerabilities in certain configurations. Enterprises started asking, how do we use something like this safely? How do we give AI agents access to sensitive systems without losing control? And how do we make sure an agent running autonomously doesn't accidentally or maliciously do something it wasn't supposed to? That's the exact problem NemoClaw was built to solve. NemoClaw is NVIDIA's open source stack for OpenClaw. It was announced by Jensen Huang at GTC 2026, NVIDIA's massive annual developer conference in San Jose. And it's not a separate competing product. It's more like a security-hardened, enterprise-ready layer that sits on top of OpenClaw, extending it rather than replacing it. The way NVIDIA describes it, NemoClaw installs in a single command, adding privacy and security controls to make self-evolving, autonomous AI agents more trustworthy, scalable, and accessible. That single command promise is real, and we're going to prove it together in this video. There are two core pillars to NemoClaw. The first is NVIDIA Nemotron, a family of open, locally deployable AI models. Nemotron lets you run inference entirely on your own hardware, which means no cloud API calls, no per token costs, no data leaving your machine. The models are optimized specifically for NVIDIA hardware, RTX workstations, DGX Spark, DGX Station, and they come in different sizes for different use cases. Nemotron 3 Nano is designed for lightweight devices where you care about speed. Nemotron 3 Super is for heavy workloads where you want maximum capability. And there are options in between depending on your GPU's VRAM. The second pillar is NVIDIA OpenShell, a runtime environment designed specifically for executing AI agents safely. OpenShell uses YAML-based policy controls, which means you can define in plain, readable language exactly what your agent is and isn't allowed to do. You can restrict which folders it can access, which APIs it can call, which network destinations it can reach, and which system commands it can execute. It creates a kind of permission sandbox. The agent has real power, but only within boundaries you explicitly define. And here's what's really clever about the design: OpenShell sits between the LLM's decision and the actual execution. So the agent can decide it wants to do something, but that intention has to pass through the policy gate before anything actually happens on your system. If the action is allowed, it proceeds. If it violates a policy, it stops, and depending on your configuration, it can alert you and ask for approval before continuing. This is sometimes called a human-in-the-loop checkpoint, and it's a huge deal for anyone running agents in production or enterprise environments. NemoClaw pairs beautifully with NVIDIA's hardware ecosystem. DGX Spark, NVIDIA's desktop AI supercomputer starting at $3,999, is designed to run NemoClaw agents around the clock as a dedicated always-on workstation. Dell has already committed to being the first to ship DGX systems purpose-built for NemoClaw workloads, with configurations supporting up to 748 GB of coherent memory. But here's the important thing, you don't need a DGX system to use NemoClaw. You can run it on a modern RTX PC, on a Linux server, even in the cloud. The goal is to make powerful, secure AI agents accessible to as many people and organizations as possible, from individual developers all the way up to large enterprise deployments. At GTC, NVIDIA even ran a Build-A-Claw event on the show floor where attendees could walk up, customize their own NemoClaw agent live, give it a name and a personality, connect it to their messaging app of choice, and walk away with it running on their phone, all in under 10 minutes. That's a pretty bold statement about how accessible they've made this. So how do you choose between them? Let me break it down in a way that makes it easy to decide. OpenClaw is the original. It's maximum flexibility. It runs on any operating system, Mac OS, Windows, Linux. It supports any AI model you want to plug in. It has a massive and growing community, over 100 built-in skills, and it's completely free and open source. If you're a developer, a power user, or someone who loves to tinker and experiment, OpenClaw is probably your starting point. The trade-off is that with great power comes great responsibility. OpenClaw gives the agent broad access by default. If you're not careful with your configuration, you can accidentally expose sensitive data or grant the agent more permissions than you actually intended. It has a steeper learning curve when it comes to security, and setting it up correctly requires you to understand what you're doing. NemoClaw, on the other hand, is built with safety as the first priority, not an afterthought. The OpenShell runtime enforces permissions before the agent can act. The Nemotron models keep everything local. The policy system is explicit, you define exactly what's allowed, and the agent cannot step outside those bounds. It's currently Linux-focused and ties you more closely to NVIDIA's hardware and model ecosystem. That's a real trade-off, and I want to be transparent about it. But for enterprises, professional teams, or anyone handling sensitive data, that trade-off is absolutely worth it. Think of it this way, OpenClaw is like giving someone a master key to your house and trusting them completely. NemoClaw is like giving someone a keycard that only opens specific rooms, logs every door they pass through, and requires your approval before entering any room marked sensitive. There's also a middle path that a lot of developers take. They run OpenClaw for personal experiments and side projects, and NemoClaw for anything work-related or anything involving production systems. The two can coexist on the same machine, and switching between configurations is simpler than you might expect. For this video, we're going to be installing NemoClaw because it gives us the best of both worlds. We get the full power and extensibility of OpenClaw underneath, with the security and privacy controls of NVIDIA's stack layered on top. And honestly, even if you're only using this personally and not in an enterprise context, there's no reason not to start with the more secure option. You lose nothing, and you gain peace of mind. Before we get to the installation, I want to give you some broader context, because OpenClaw and NemoClaw didn't emerge in a vacuum. They're part of a seismic shift that's been building in the AI world, and understanding that shift will help you see why these tools matter so much. For the past few years, AI has mostly meant chatbots. You open a browser tab, you type a prompt, you get a response. That model has been incredibly useful, genuinely transformative in many ways, but it's also fundamentally passive. The AI sits there and waits for you. You do the work of deciding what to ask, when to ask it, and then you take the answer and go implement it yourself. The AI is a very smart advisor that never actually does the work. What's changing in 2026 is the shift from AI as a responder to AI as an actor. These new agentic systems don't just generate text, they take real actions in the real world. They execute code. They browse websites. They send emails on your behalf. They call APIs. They manage files. They coordinate between services. They can work through the night while you sleep and have a full report ready when you wake up. This category is called Agentic AI, and it's arguably the most significant development in applied AI since the large language model itself became capable enough to be useful. The models are now smart enough to reason about multi-step tasks, recover from errors, and make judgment calls, which is what you need to actually trust an agent to act autonomously. OpenClaw was the first project to make Agentic AI truly accessible to everyday developers and technically curious consumers. Before OpenClaw, setting up an AI agent that could do real things required deep knowledge of LangChain, custom infrastructure, DevOps skills, and a lot of time. OpenClaw collapsed all of that into a single install and a configuration file. The numbers tell the story. OpenClaw went from 0 to 180,000 GitHub stars in just a few weeks, a rate of growth that has no real precedent in open source history. The developer who built it was recruited by OpenAI shortly after. NVIDIA, the world's most valuable semiconductor company, saw it and immediately built a dedicated product around it. That's not something NVIDIA does lightly. We're at an inflection point that feels a lot like 2008, when the iPhone App Store launched and suddenly everyone could build software that lived in people's pockets. AI agents are about to become as common and as personal as mobile apps. The infrastructure being built right now, OpenClaw, NemoClaw, and the tools that will follow, is the foundation of that shift. And by installing this today, you're not just following a trend. You're building real understanding of a technology that is going to matter enormously. Let's take a look under the hood, because I think understanding how these agents actually work makes them way less mysterious and honestly makes you a much better user of them. At the center of any AI agent is something called a reasoning loop, also sometimes called an action loop or a react loop, which stands for reasoning and acting. It goes like this: the agent receives a goal, it thinks about what steps are needed to achieve that goal, it selects and executes an action, it observes the result of that action, and then it reasons again based on what it learned. It repeats this cycle until the goal is complete or until it encounters something it genuinely can't handle and asks for human input. In OpenClaw's case, this loop is powered by whichever large language model you've connected. You send a message through WhatsApp or Telegram, that message gets passed to the LLM along with a description of all the tools the agent has available: browser control, shell access, file read and write, email sending, and so on. The model reads the task, reasons about the best first step, selects a tool to use, OpenClaw executes the tool call, the result comes back, and the model decides what to do next. This continues until the task is done. Memory is one of the most important and underappreciated parts of what makes OpenClaw powerful over time. Unlike a chatbot that forgets everything the moment you close the browser tab, OpenClaw stores context as plain markdown files on your local disk. Every significant task, every preference you express, every piece of information the agent learns about your projects, it's all stored and retrievable. Over time, the agent builds a surprisingly accurate picture of how you work and what you need, without you having to re-explain yourself every session. The skills system is how the agent's capabilities expand over time. A skill is essentially a folder that contains a skill.md file describing what the skill does, what inputs it expects, and how to use it. The agent can search for skills in the ClawHub community registry, download and install new ones, and even write entirely new skills for itself when it encounters a task it doesn't know how to handle. This is what people mean when they describe OpenClaw as self-evolving. NemoClaw adds a critical safety layer to this architecture. The OpenShell runtime sits between the LLM's action decisions and the actual execution on your system. Every time the model decides it wants to run a command, access a file, or make a network call, that decision goes through OpenShell's policy engine first. The engine checks it against the rules you defined in your YAML config. Allowed? It runs. Not allowed? It stops immediately and logs the attempt. You can also configure certain action categories to require your explicit approval before they execute, which is exactly the kind of control you want if you're running an agent with access to production systems. Let me be very direct about who should use what, because I get this question constantly in the comments. You should start with vanilla OpenClaw if you are a developer or technically confident user who wants maximum flexibility and is comfortable managing security yourself. If you want to experiment with different AI models, build and share custom skills, connect to any cloud provider you want, and run on macOS or Windows, OpenClaw is your home base. The community is enormous, the documentation is solid, and you'll find answers to almost any problem on GitHub or Discord within hours. You should use NemoClaw if you are working in a team or any kind of professional context, if you're handling data that matters, client files, financial records, internal code, confidential documents, or if you simply want a setup where you don't have to think too hard about whether the agent might accidentally do something harmful. NemoClaw is also the right choice if you have NVIDIA hardware, because the Nemotron models are specifically optimized for RTX GPUs and DGX systems, and you will get significantly better local inference performance compared to running a generic open-source model. And honestly, even if none of those enterprise concerns apply to you, even if this is purely personal use, I still recommend starting with NemoClaw. The install is just as simple. You get everything OpenClaw offers plus the safety layer on top, and you build the right habits from day one. There's really no downside. Many developers I know run both NemoClaw for anything that touches real data or production systems, OpenClaw in a separate sandbox for experiments. The two configurations can live comfortably on the same machine. Before we jump into the terminal, I want to leave you with some concrete examples of what people are actually doing with these tools right now, because I think hearing real stories is the best way to understand what's possible and to spark ideas for your own use cases. The car negotiation story has become legendary in the community. A developer named AJ Stuyvenberg gave his OpenClaw a single instruction: get me the best deal on a specific car model within 200 miles. The agent scraped dealer inventories, filled out contact forms with his details, and spent 4 days playing dealers against each other, forwarding competing quotes and asking each dealer to beat the lowest offer. Stuyvenberg's total involvement was reading his summary email each morning. Final result: $4,200 below sticker price. He showed up, signed, and drove home. Another community member had a Lemonade insurance claim rejected. Without any specific instruction, their OpenClaw agent found the rejection email in the inbox, cross-referenced it against the original policy document on the user's hard drive, drafted a formal rebuttal citing specific clauses in coverage language, and sent it. Lemonade reopened the claim. A graduate student at ETH Zurich set up their NemoClaw on a university Linux server and connected it to their Obsidian Notes vault, their university calendar system, and their email. The agent now tracks deadlines, sends draft reminders before papers are due, and has built a skill to automatically format citations according to whichever style guide the student specifies. It's like having a very organized research assistant running 24 hours a day. On the enterprise side, a logistics company is using NemoClaw to automatically extract shipping details from PDF invoices, cross-check them against their warehouse system, flag discrepancies, and send exception reports to the operations team, a process that used to require 3 staff members working full-time. These are not hypothetical future possibilities. These are things happening right now, today, by real users. This technology is accessible, it works, and it's only going to get more capable. Alright, enough talking. Let's build yours. If you enjoyed this video, don't forget to like, comment, and subscribe.